Steady state exercise is when lactic acid is produced at the same rate as it is removed from the body. This happens in exercises such as on the treadmill, on a bike, or swimming. During exercise, your cardio system has many responses such as your heart rate changing. This increases a certain amount and then steadies out. This is shown in the diagram below. Just like heart rate, stroke volume also increases to a maximum effort, then steadies it out a bit. When exercising in steady state, there is an increase in venous return, which means that more blood is supplied to the heart, which stretches the cardiac muscle. Because of the stretching in the muscles, a greater force in the contraction occurs. Therefore, more blood is pumped out per stroke. Therefore, an increase in stroke volume happens. This is also called Starling's law. All these responses happen and all these changes occur because our muscles need more oxygen for them to work faster. The only way they can get oxygen is through the blood. Therefore, the amount of blood that's pumped around our body needs to be increased in some way or another. During steady state exercise, our cardiac output increases. This increases because the heart rate and stroke volume also increases. And cardiac output is heart rate times stroke volume. This all increases because the body needs more oxygen and the muscles require more oxygen. The oxygen is carried in the blood, so the muscles require more blood. Just like everything else, cardiac output increases to a maximum and then steadies out. The body's natural temperature is 37 degrees. If this changes by even 1 degree, minus or positive, this can completely affect a person's performance. Thermoregulation is controlled and set by the cardiovascular system. Our blood is what keeps us warm and gives us our warmth that we have now. We get cooler by sweating and dilation of our veins. When our body is too hot, our veins vasoconstrict, meaning that they tighten, meaning that less blood goes through, keeping us cooler. When our body is too cold, our veins vasodilate, meaning that they widen, so more blood rushes to each muscle, giving us more warmth. This will increase and decrease depending on how hard you work and the environment, whether it's in a hot environment or a cold environment. Just like I said in the slide before, all these happen for the same reason. The reason is our body, and especially our muscles, need more oxygen as we are working harder. The only way they can get oxygen, like I said in the slide before, is through the blood. So we need to get more blood around the body so our muscles can get more oxygen. This can happen in many ways, as I show you here. Just like cardiovascular, respiratory is the same. Everything that we see here, and everything I'm going to talk about, will increase to a certain level when it's maximum and then steady out. When exercising in a steady state, breathing rate increases and then steadies out. This is because muscles need more oxygen as it meets its demand. As the muscles need more oxygen much quicker than usual, they have to take more breaths more quickly, meaning more oxygen can come in. As more oxygen is coming in, we need to get rid of more CO2, so we need to breathe out quicker and breathe in quicker, meaning our breathing rate increases. Tidal volume. This also increases and then steadies out. This increases because the body and the muscles need much more oxygen than usual, so the depths of breaths increase to a maximum amount. This is very similar to stroke volume. Instead of blood, it's oxygen. As we are taking more breaths, much deeper, more oxygen comes in and more CO2 comes out each breath, as there is a wider surface area as we open our mouth. Oxygen dissociation curve. Oxygen reacts with hemoglobin to form oxyhemoglobin. The amount of oxygen that binds to hemoglobin will depend on the partial pressure of oxygen. For example, when the oxygen is in the lungs, it is in a high concentration, so lots or all oxygen attaches to the hemoglobin. But when the oxygen gets to the muscles, there is a low concentration, which meaning that the oxygen will detach. When the carbon dioxide and pH levels change, it can move the curve right or left. This happens because the higher the levels of carbon dioxide, the higher the acidity is, which makes the curve move right. When there are low carbon dioxide levels, there are less acidity, which means the curve moves to the left. Just like carbon dioxide, temperature also makes a big difference to the curve. The warmer the body is, for example, your muscles, the more oxygen will be dropped off, meaning the curve will move to the right. The cooler your body is, for example in your lungs, meaning that more oxygen will be binded. When the temperature of our body decreases, the curve will shift to the left. But when the temperature of our body increases, the curve will shift to the right. The respiratory system is very similar to the cardiovascular system, but instead of blood, it's to do with mainly oxygen. All these changes and responses that I've shown here all happen because our body and especially our muscles need more oxygen as we are working harder. So our body has to change and do things differently so we can bring more oxygen in so our muscles can keep working. And our body also needs to change so we can breathe more to bring out CO2. During steady state exercise, warmed up muscles become more pliable, meaning that they can stretch more and move more without tearing. As the muscles are much warmer, the rate of nervous impulses increases, meaning that they can move more and become more flexible. Speed of transmission is how quickly each muscle gets the nerve signal to move. This increases as heat increases. So when your body gets warmer, the transmission of speed increases. All these responses and changes I've told you about neuromuscular that happens, it happens because our body needs to get heated up. Because if our body is heated up, our muscles are more stretchy, more flexible, and have more movement. So this happens to prevent things like injury, as we can move more and won't be as stiff. An example of someone using pliability is a goalkeeper when they are warming up before a match. This is so they can stretch more further and have a better reaction time. The reason our speed of transmission increases is so that our reaction time can increase. For example, a goalkeeper, they stretch out before a match and warm up before a match so they can react quicker to make saves. The aerobic system. This energy system is what gives us most of the energy. Although the process is slow, it gives us a massive amount of energy each time and each reaction. Aerobic glycolysis. In this stage, glucose breaks down to make it suitable for the presence of oxygen. The glucose that breaks down is turned into pyruvate. Because of the oxygen present, it goes into a series of reactions known as the Krebs cycle and the electron transport chain. In the Krebs cycle, this is where pyruvate combines with coenzyme A, known as CoA, which form acetyl-CoA. This produces ATP, hydrogen, and carbon dioxide. The next reaction is the electron transport chain. This is where hydrogen atoms form Krebs cycle and to enter the chain. They pass along and combine with oxygen form more ATP. This all takes place in the mitochondria. The folds that you can see in the diagram below are called cristae. These are there to increase the surface area of the whole thing. This increases the amount of energy produced each time, so it increases energy production. Anaerobic glycolysis. Anaerobic glycolysis is a breaking down process in which glucose is broken down without the use of oxygen. Like aerobic glycolysis, which breaks down glucose in the presence of oxygen, it produces energy for the cells. When they break down glucose without oxygen, this produces lactic acid. However, when the process is made to take longer, it generally leads to lactic acidosis, which is a decrease in the pH level of the blood. Long term short, basically, anaerobic glycolysis is very similar to aerobic glycolysis, but instead of using oxygen, this is without oxygen. Just like aerobic glycolysis, this is a type of energy source and energy production, so this gives us energy. An example of this is when we're at the higher pressure and the higher state of exercise, meaning that we don't use the oxygen as don't breathe as much, as we want to push as much power through our body as we can.